Hello friends, welcome to engineering tutorial. So we'll continue our discussion related to power systems. So far we have discussed various concepts related to polyphase circuits in the previous videos and about the various parameters, basic concepts, introductory concepts related to parameters associated with the conductors or transmission and distribution line systems. Basic concepts, we have not gone too deep into it. So in this video we are going to discuss the basic layout, the basic introductory concepts related to the power supply system, which will be in the form of AC. So AC power supply system, basic layout, the basic introductory concepts related to it. So the power supply system, basically the AC supply, which we talk about here in this video, it is the transmission and distribution of electric power, the conveyance of electric power, which is basically transmission, distribution. So generation will already, that goes without saying. The generation, transmission and distribution of electric power from a generating station or power station to the consumers, the households, the localities. So that is called as the electric power supply system. So this conveyance, it consists of three main elements of the power supply system. First is generation. At the power station, the electric power is generated. It has different sources. That is a different topic of discussion. So first is generation, second is transmission, to move the electric power from one point to another, and then distribution, distributing or giving the electric power depending upon the requirement of different consumers. For example, household localities, households, they have different power requirements. Industrial purposes, it has different power requirements. So depending upon that, various circuitry is introduced at different points to make some manipulations, some changes in the voltage, basically with the help of transformers, stepping up, stepping down, or with the help of various power electronic components to change the nature of the power, AC, DC, depending upon the requirements. So that comes under distribution. So the three main elements are generation, transmission and distribution. So again, these three are accomplished. First, the generation happens from the power station, the power plant. Transmission happens through the transmission line cables or conductors, and distribution system also is a network of conductors or cables to distribute the power with its own circuitry to make the changes depending upon the requirement of various consumers. So first, the electric power is generated at the power stations, which is located at favorable places, generally quite far away from the consumers. For example, if we are talking about a hydropower plant, it is located near a place where water is available in abundance. For a thermal power plant, it is located near a place where coal is available in abundance. The nuclear power plant, it is located near a place where nuclear fuel is available in abundance, and that is generally far away from the commercial or household places. Then it is the electric power which is generated at the power station. It is transmitted over long distances to the load centers with the help of a network of conductors, cables, transmission lines. These are called as transmission lines. And then, as I said, it is distributed to a large number of small and big consumers depending upon their requirement, the magnitude and nature. okay, whether it is high voltage or low voltage requirement, or AC or DC requirement. Depending upon that, the distribution network operates differently with the help of appropriate circuitry installed at different places. So basically we can categorize this whole electric supply system into two categories. First, the DC and AC, and then from the generation and different transmission and distribution point of view, and from the transmission and distribution point of view, with the help the manner in which it is transmitted and distributed, that is the overhead system and the underground system, the cabling, the network of conductors. So if poles, towers and wires hanging in support with them, that is the overhead system, and if the cables are buried underneath inside the surface of the earth, that is the underground system. We'll have a detailed discussion about it in a separate video. So this is just you know that this is the thing. And as I said, as we discussed the polyphase circuit, mainly the 3-phase 3-wire or 3-phase 4-wire, that system is adopted for the transmission and distribution of electric power. So you can watch the polyphase circuits and the interconnection of the 3 phases in a 3-phase circuit, whether it is star or Y connection and delta connection, that to have some more knowledge about it. Okay, so this is the thing. Now here we'll discuss the basic layout, the basic power supply scheme for the power supply in the form of AC. Okay, so here, as I said, there are 3 main elements. Okay, there are 3 main elements: generation, transmission and distribution. Generation happens at the power station, transmission happens through a network of conductors or cables, which is called as transmission lines, which move the electric power from one point to another, and the distribution, also a network of conductors with appropriate circuitry, which provide electric power depending upon the requirement to the various consumers. So this basic power supply scheme, the AC power supply scheme, it consists of the following elements. So first is the generation or the generating station, the power station. Then we have the transmission system, which is divided into 2 parts: primary and secondary transmission. Okay, then the distribution system, again divided into 2 parts: primary and secondary distribution. We have the receiving station, the substation, and the step up and step down transformers and other elements. So first, the generating station. Okay, so here the generating station, it is the point where the electric power is produced by 3-phase AC generators called as alternators, which operate in parallel. Here the generation voltage, that value is very important. The usual generation voltage value is 11 kilovolt. Okay, but for economic considerations, from the transmission and distribution point of view, this generation voltage value 11 kilovolt, that is stepped up using step up transformers. It is stepped up to a value of 132 kilovolt or more, but generally 132 kilovolt. It happens at the generating station. So this is the single line diagram or line diagram which is used to represent the general AC power supply scheme. So I request you to please draw it, okay, before watching this video, because I have used it in segments in the different parts. So from the generating station up to the end, to the consumers, just draw it, okay, the generating station to the last end, the single line diagram or the line diagram. Okay, and these kind of diagrams are used to represent the various elements in the power station. the power systems. So just draw it, okay, and then watch the video. This is the straight line diagram which will be used to represent the different systems. So first we have the generating station. The generation voltage is 11 kilovolt. It is stepped up to a value of 132 kilovolt at the generating station itself, and then after it is stepped up to 132 kilovolt, it is then transmitted, and this forms the primary transmission. Okay, this forms the primary transmission. Okay, the first part of the transmission, which is the primary transmission. Now you will ask why it is transmitted at high voltage. Now this has its own advantages why it is transmitted at high voltages, and I will make a separate video on it, why transmission voltage, high transmission voltage is used, what are its advantages. So for now you understand, with the help of three-phase step-up transformers, this voltage is stepped up to 132 kilovolt and then it is transmitted, and this forms the primary transmission. So generally the efficiency of transmission is increased, and also the conductor material, the number of conductors that are required, the area, that is reduced. But in detail I will make a video about it, so don't worry about that. So here, after it is increased to 132 kilovolt, the primary transmission happens, and this primary transmission voltage, depending upon different requirements at different places, it is carried at 132 kilovolt generally, but other voltages that can be used are 66 kilovolt, 220 kilovolt or 400 kilovolt. But generally here at 132 kilovolt the primary transmission happens. Then the secondary transmission. So this electric power at 132 kilovolt, it is transmitted by a three-phase, three-wire overhead system. Okay, three-phase, three-wire overhead system, this way. Okay, so whether it is star connection or delta connection, that is decided as per the various factors which govern that at that particular place. So it can be star or delta. Okay, so then this kind of transmission, this is called as high voltage AC transmission, HVAC transmission. Okay, so this primary transmission line, it terminates at the receiving station. Okay, it terminates at the receiving station. Okay, and at the receiving station the voltage is reduced to 33 kilovolt by a step down transformer. Okay, 132 to 33 kilovolt at the step down transformer, and this happens all at the receiving station here. So this is actually a very long downward flowing straight line diagram. I have divided into into various parts. Okay, I've segmented it. So this is the first part, starting from the generation station, 11 kilovolt, stepped up to 132 kilovolt. That is the primary transmission, three-phase, three-wire system. Then it is stepped down to 33 kilovolt at the receiving station, and this is the receiving station. Okay, it terminates at the receiving station, and then after it is stepped down to 33 kilovolt, it is the electric power at 33 kilovolt. Again, it is transmitted by three-phase, three-wire overhead system to various substations which are located at different strategic points in the city or wherever the location is. Okay, from the receiving station it is transmitted according to the requirement to different places. Okay, to the various substations. Then happens the distribution part. So the distribution part, again, it has two main parts, primary and secondary distribution. So the secondary transmission line, it terminates at the substation. Okay, it terminates at the substation, this place. Okay, this is the substation. This is the substation at where the primary transmission line it terminates. Now at the substation, the voltage is again reduced from 33 kilovolt to 11 kilovolt with the help of a step down transformer. Again, 3-phase 3-wire system. The voltage is again reduced from 33 kilovolt to 11 kilovolt at the substation. And this 11 kilovolt line, transmission line, distribution line, sorry, it runs along the important roadsides of the city, and this forms the primary distribution. Okay, now here another important thing, as I said, in the distribution system there are different kind of power requirements for different consumers. For household communities the power requirement is generally less, but for industrial level consumers the power requirement is high. So depending on that, for big consumers the supplied power at 11 kilovolt can be stepped up with their own circuitry. At the industrial sectors, they have their own circuitry which step up the power, and then it is altered whether it is AC or DC with the help of required circuitry. Generally the power electronic components, they have their own circuitry. Okay, and then we have from the primary distribution line 11 kilovolt is distributed to the various substations, and these substations they again step down the voltage to 400 volt, from 11 kilovolt to 400 volt. From the primary distribution line it is again stepped down to 400 volt using a step down transformer. Okay, in the substation again, and this is a 3-phase 4-wire secondary distribution. So understand, from the substation the 11 kilovolt is again stepped down to 400 volt, 11 kilovolt to 400 volt. Okay, so here the voltage between the two phases, that is 400 volt, and between the phase and neutral, that is 230 volt. Okay, this is the important thing that you must understand, and this forms the secondary distribution. Okay, this forms the secondary distribution. So again, understand, first at the generating station 11 kilovolt, it goes and there is a step up transformer which increases this 11 kilovolt to 132 kilovolt, because high transmission voltage has advantages of higher transmission efficiency and reduction in the size of the conductors which is required. This 132 kilovolt line, that forms the primary transmission. Okay, then at the receiving station it is stepped down to 33 kilovolt. Okay, it is stepped down to 33 kilovolt with the help of appropriate 3-phase transformers. Then this 33 kilovolt line, that forms the secondary transmission, and again it goes to the substation, another substation which is located at strategic points in the city, where another step down transformer is used which reduces the voltage to 11 kilovolt. It goes to another substation. This 11 kilovolt line, that forms the primary distribution. Okay, that forms the primary distribution. Depending upon requirement it goes to different places, and at appropriate places then at another substation the 11 kilovolt is again reduced or stepped down to 400 volt. Okay, 400 volt, which is the voltage between two phases, and the voltage between a phase and neutral, that is 230 volt. And this 400 volt between two phases and 230 volt between phase and neutral, that forms the secondary distribution, which again goes to the consumers. Now you have to understand this secondary distribution line. Okay, this secondary distribution line, it can again be represented in the form of this. So the secondary distribution system, it can be represented in this way. So it consists of three main parts. Okay, feeders, okay, distributors and service mains. Okay, so from the distribution station, the secondary distribution station, the feeder lines, which are SC and SA, okay, that they provide to the distributor lines, which are AB, BC, CD and AD. Okay, this is S. Okay, this SC and SA, they provide, which are the feeder lines, they provide to the distributors, which is AB, BC, CD and DA, and they provide to the service mains. Okay, feeders supply to distributors and distributors to service mains. Here the important thing to understand that the consumers, they are not given direct connection to the feeders. Okay, the consumers are connected to the distributors through the service mains. Okay, feeder lines to distributor, distributor to consumer through service mains. Okay, this is the secondary distribution. This forms the network of the secondary distribution. So again, this can be a little bit confusing and complicated at first, but as you watch the video more and more and draw the rough diagram, the straight line diagram, then practice it a few times, you will get a hang of it. So first, the generating station, I am repeating again, 11 kilovolt generation voltage. It is stepped up to 132 kilovolt for economic consideration in transmission. After it is stepped up to 132 kilovolt using three-phase transformers, it is transmitted overhead, that is the primary transmission. Then it reaches the receiving substation where it is stepped down to 33 kilovolt using three-phase step-down transformer. Then this 33 kilovolt from the receiving station forms the secondary transmission. Again overhead, three-phase, three-wire system. Then at another substation, this 33 kilovolt is stepped down again to 11 kilovolt, and this 11 kilovolt line that forms the from the substation, that forms the primary distribution, line, the 11 kilovolt line. Again at another secondary distribution substation, this 11 kilovolt is again reduced or stepped down to 400 volt, which is the voltage between two phases, and the voltage between a phase and the neutral, that is equal to 230 volt. Also this is very important, the voltage between the phases and the voltage between a phase and neutral, that is 230 volt. So this forms the secondary distribution. The secondary distribution again is divided into three parts: feeder, distributor and service mains. From the secondary distribution system station, the feeders connect the secondary distribution substation to the distributors. The distributors are connected to the consumers through service mains. No direct connection between feeder and consumers. Okay, so this is the basic overall layout of a AC power supply system. Okay. So this is the straight line diagram. As I said, I have divided the straight line diagram into various parts, segmented it. So this is the whole thing. Okay, so first is the generating station here. Okay, 11 kilovolt. Then we have the step up transformer, which steps up to 132 kilovolt, which forms the primary transmission. Again, the primary transmission, it terminates at the receiving station where it is stepped down using 3-phase transformers to 33 kilovolt. All of this happens overhead, 3-phase 3-wire system, 3-phase transmission. Then this 33 kilovolt line that forms the secondary transmission. Again at the substation, the primary distribution substation, it is stepped down to 11 kilovolt, okay, and this 11 kilovolt line that forms the primary distribution. Again at the secondary distribution substation, it is again stepped down to 400 volt, which is the voltage between two phases, whether it is star or delta connection. To build voltage between two phases, and the voltage between a particular phase and neutral, that is 230 volt. So that voltage, the 400 volt or 230 volt, that forms the secondary distribution line. And the secondary distribution line, again it has other circuitry which we'll discuss. Okay, so this is the whole thing, okay, from start to the end, which was divided into various parts. Okay.